Prime factorization and product of primes. In this video, we're talking about prime factorization and how to use prime factorization to find the product of prime numbers. We're going to do, for example, the first one is number 102. And we want to find the prime factors of 102. So remember that the prime number is a number which is only divisible by 1 and itself. So 1 is a special number, but 2 is a prime number that only factors of 2 are 1 and 2 itself. 3 is also a prime number because it's only divisible by 1 and itself. 4 is not a prime number because you can divide it by 1 and itself, but also you can divide it by another number 2, which means that 4 is a composite number. So that's just basic review, but what we want to do here is find all of the prime numbers that have to be multiplied together in order to get 102. So when we're dealing with an even number, 102 is an even number. When we're dealing with an even number, the easiest way to start factoring is to divide by 2. Because we know that all the even numbers are divisible by 2. And 2 is a prime number. So we want to go ahead and divide by 2. And that we need to do is say what do we have to multiply by 2 in order to get 102. In other words, what's 102 divided by 2? Well, that's 51. So we get 2 and 51 as the factors of 102. Now we want to look at each of these numbers and see if we can factor them further. Well, we know that 2 is already a prime number, so we cannot factor it any further. But what about 51? Well, 51 can be separated into factors of 3 and 17. Because 3 times 17 is 51. 3 is a prime number because it's only divisible by 1 and itself. And 17 is also a prime number because it's divisible only by 1 and itself. We know we can't go any further. So we're done with our prime factorization. And then if you want to find the product of primes, all we do is take all of our prime factors and multiply them by together. So 2, 3, and 17 are the prime factors that make up 102. So we just say 2 times 3 times 17 equals to 102. If you look at another example here, we have 84. This is also an even number, so let's go ahead and divide it first by 2. 2 times 42 equals to 84. So we will divide 84 into 2 and 42. 2 is a prime number, but 42 is not. 42 is a composite number. So we will divide 42 into 2 and 21. 2 is a prime number again, but 21 isn't. 21 can be divided into 3 and 7. So now what we can see is that at the end of each road here, at the end of each path, we have a prime numbers. 2, 3, and 7 are all prime numbers. So we can't go any further. This is the prime factorization, and the product of prime is going to be 2 times 2 times 3 times 7. Now when we have multiplied factors of the same prime number, we can rewrite this as 2 squared times 3 times 7. And we always want to list our factors in ascending order. So smallest factor first up to the largest factor. Looking at another example here, 24. 24 is an even number, so we can divide by 2 if we want to get a 2 and a 12. But let's say instead that we maybe forgot that we have 2 and 12 as factors. And we want to divide instead into 4 and 6. Because 4 times 6 is equal to 24. Then we could say 4 is divided into 2 and 2. And 6 is divided into 2 and 3. And now we can see that at the end of each path we have a prime number. Because 2 is a prime number and 3 is a prime number. So we know that we are done with our prime factorization. And we now want to say that the product of prime is 2 times 2 times 2 times 3. That will be equal to 24. Or we can rewrite it as 2 cubed times 3. We still does 3 factors of 2 and 1 factor of 3. Now, the first 3 example here, we have had an even numbers, but sometimes we're going to have an odd number. And with an odd number, we just know that we're not going to be able to divide by 2. But that doesn't mean that we can't factor it. So, for example, let's say an odd number like 15 here. We can divide it into factors of 3 and 5 because 3 times 5 will be equal to 15. 3 and 5 are both prime numbers, so we know that we're done, and we can say that the product of primes is 3 times 5 for 15. In other words, no matter what the number, you're just looking to break down into prime factors. So at the end of each path, you should have only prime numbers, and then you take all those prime numbers and multiply them together to find the product of prime.